The only ones I ever think of are Titans.
Yep.
I think I have to see it to believe it.
I always get like one that's in the AFC South, or one that's in the AFC West.
Homework's due at some point today. Make sure you get it turned in. Make sure your name's on it. All that good stuff. Okay. All right. Today, because you'll get a little bit of time right now to work on it here in a little bit. I want to talk about your practice guide. Let's have that out. Did anyone not get one yesterday? Are you gone? You don't have one. Because if you're on that like foods trip, you probably don't have it. So anyone need the practice guide?
Soccer, is that folder you have? No folder?
Anyone else need one?
Every teacher tells me I need one.
Well, that must have been something that you guys love.
All right. Today, here's what we're gonna talk about. I want to go through these last 6 problems today. We talked about number 6 yesterday. My goal is to go through 7 through 12 today. Now I know we don't have a lot of time, but we have enough time to go all the way through 6 of these. So we're on the back side now. We're going to start with 7, 8, and 9. Now on these, all they ask you to do is simplify them as far as you can. You got to do the performed operation correctly, and once we're done, we have to read off exceptions to the domain, things that you cannot use in this problem. Okay, like right now, I can tell you right from the start of number 7, you cannot use number 3 in the very end. Just starting that problem, you can't use that. In fact, if we actually split this up as well, I think you can't use -3 as well. So -3 and positive. For right now, it may simplify later, but starting, I know those are exceptions. So in fact, I'm going to write those down right now. So x cannot be -3 or a +3 as we sit right now. Can't do it. So those are going to be exceptions because this part right here actually factors in part. It's x plus 3, x minus 3 is the difference of squares, right? So I know for right now, that's what we have. Now, how do you do division? What's the rule?
You flip the reciprocal.
Yeah, you do the reciprocal, right? So you got to flip the back fraction over. That's called the reciprocal, and we'll go from there. So even though that back fraction is flipping over, for right now, you're not allowed to write it like that. So, or we're not allowed to use 3 -3s. Okay, up here, is there anything I can do on the top of this one? I got a 2. That's pretty much about it. So I take out a 2. What am I left with?
2x squared plus 5.
2x squared plus 5, and that cannot factor any further. I mean, it's not even a difference of squares. It's not even a cube rule because it has a plus. So it's not a difference of squares, and it's not a cube rule because it doesn't have a power of 3 from the x. The bottom, I really can't do anything with that. So I'm just leaving it alone. All right, but over here, I flip the second fraction over, so it looks like this mess goes to the top. That was on the bottom, right? But what is this? How do I factor this thing? Yeah, 3. And if they got a 3, what am I left with?
Squared plus 5.
Squared plus 5. Oh, that's nice. All right, now, before I start canceling stuff, now that we're here, does this make sense for how we did that?
Yes, sir.
We flipped the second one over. We factored everything apart. I know things are going to cancel here, but we still had exceptions. Right? We still had certain problems or certain numbers you couldn't use. You can use +3, -3. And is there any way that I can make that thing 0?
No.
No. There's no way this thing will ever be 0. The reason being, you're squaring a number that will always turn it positive. You're going to take it times 2, and you're going to have to add it to 5. So there's no way. I mean, the minimum that thing could be is 5. Because even if you plug in negative numbers, you're going to square them, making it positive, taking it times 2 and adding it to 5. The smallest number you could technically plug in there is probably a 0 in right here. And the smallest system you will make is 5. So there's no problem. There's no exceptions to that thing. But things canceled, correct?
Mm-hmm.
What items canceled?
X minus 3.
So 3's are gone.
And then 2x plus squared plus 5.
3's are gone. And what we're left with is just that stuff on the top and the 3 on the bottom. Okay? And that's your final answer. I mean, that's what you end up with. And then, so once you write that down, you just go that way and write whatever's left. Then over here, you've got to make sure that you're writing the exceptions. That should be somewhere on your paper. You cannot use those 2 numbers for sure. Okay, makes sense for how you're doing that.
Would it be okay to distribute the 2 to the x plus 3?
You can do that. You wouldn't need to. I I don't require you to go further. I mean, you just leave it there, as long as you cancel something. Okay. All right, we're comfortable with 6 and 7. I know 6 is roughly the same style, right? Question.
This must be a positive to the bottom.
Yeah, I've been trying to figure this out for like 5 minutes.
Which one?
X squared plus 3x plus 2, bottom of the grade for fraction.
Is that the
I don't know. I pulled it right from the book. Let me double check the book. Maybe I checked it wrong. I don't think it is. Because maybe it's not factorable.
Well, if you do plus 2, then
It would be factorable, yeah, because you make the plus and right.
and then it has
Alright, let's double check. Is that an adding subtracting problem? Maybe I typed it in mine.
Yeah, I've been trying to like think about this for like 5 minutes.
Let's see.
How does this work?
Yeah, hey, that is a plus 2. My bad.
Are we
Hey,
gonna
put a
fix
plus.
class today?
Yeah, hey, put a plus. Yeah, I'll make sure I fix that for those. Hey, yeah, put a plus on the bottom there. Sorry, my bad. I must have just typed it in fast. So, okay, okay. Any questions with how to change that problem right now? Okay, so before we start, let's figure out the exceptions on this problem. So I'm going to factor this thing apart. Those are already factored. So, and then what we can do is once we have this thing broken apart, then we can figure out what the exceptions are in my problem. Okay, on this one, we're not going to multiply everything by the common denominator. We don't need to do that. What we're going to do is we're just going to make common denominators and add the fractions together. Because I'm not trying to solve things. I'm just going to try to simplify.
Could you scroll that one up?
Yeah, I'm going to put it on the top here. All right, so, okay, so we got a plus sign here. My bad. I didn't even realize I didn't do that. All right, so put a plus. Okay, so let's factor the bottom. So this turns out to be, if I factor this apart, it's a plus plus, x and x, 2 and 1. And that makes sense. So, all right, so what are my exceptions right now?
-2 and -1.
-2 or -1. So those are definitely numbers we cannot use right now. Now, if we simplify it later, I mean, these are still exceptions. Okay, are we good with the exception rule, like how that works? Okay, now at this point, what we're going to need to do for the rest of the problem is we need to get common denominators on every single fraction so we can add them together. Okay, so right here, that one's good. This is the common denominator for everything, so you can kind of see it. Every fraction should have an x plus 2, x plus 1 on it. So that one's good. That fraction will be the same. In fact, I'm going to leave that alone. I don't really care about the top for right now, just because I know I'm going to have to add it with the top later, so I'm not going to factor the part. I'll just waste time. But over here, do I need to introduce anything on this fraction? Yeah, I need to put an x plus 2 on it, right? To make sure it has a common denominator. That means I have to put the x plus 2 over here. I need to make sure I have the same items top and bottom. Okay, over here, did I have to introduce anything new?
X plus 1.
X plus 1. Well, I need to make sure I put that on the top as well. Okay, questions with that? Okay, now, when you add or subtract straight across, this is the tricky part. The bottom is not going to change. You're going to have one huge fraction. And what's on the bottom? That is all you're going to have. X plus 1, x plus 2. That's all you have. Notice, I'm not multiplying anything. You know, it's just when you add fractions, the denominator stays the same. You're not combining them. You're not going to make a bunch of those parentheses down there. It's just those two. So they're all matching. The top, on the other hand, has to add all or subtract all together. So here's what I have on the top. Does that make sense? Like how I got the top? Now the reason, why did I write it like that? Why did I write the top like that?
So you're not confused.
Yes. That's the number one thing. So you're not confused, you're not going to get the wrong answer on the top. I didn't do any of the math. I didn't distribute or anything like that. I wrote down exactly what the tops were, adding or subtracting them as I go across. Then what we'll do next is then I'll distribute and do all the other stuff. The reason why is I need to make sure that when we distribute this, what goes with the 3x? Negative. And some people get that wrong. Or on this one, you distribute the positive 5. 3. That's just something I know people will get wrong, especially on negative stuff. Okay, then once you're done, once you've added or distributed and combined terms, then you try to factor that thing apart if it's possible. Sometimes it's not. Sometimes you add everything together and there's just nothing you can do. It's not mean, that would be just your final answer. Okay, questions, comments, concerns on 8?
Can you keep going?
Yep. All right, I think I've got you plenty far enough. Okay. On these, so far on these problems, 7 and 8, this is the types of problems you should be expecting. Something where add and subtract across, get common denominators, measure, type of thing. It's not going to be tricky, it's just, you know the basic rules. That's all I'm testing you on. All right, 9, let's scroll up. Okay, so 9, this is that problem that has complex on it. Every item that you see here is a fraction. That's what you need to realize. Everything is a fraction because this little thing threw everything off. So I'm going to rewrite this a little bit different so you can see this. This is what I mean. We have fractions on every single item. Top left, top right, bottom left, bottom right. You see that all 4 items are fractions. Even though it doesn't look like it. Now the reason why you do that is so now you can figure out what is your common denominator on all 4 of them. Exactly. It's an x plus 3 and number 1. Does everyone see that those are on the bottoms of all 4 of those fractions? That's what you're going to multiply everything by. Because technically what I'm doing is I'm multiplying this whole mess by the number 1. Well, instead of choosing 1 with 1, good, I'm going to choose this. Because that's your common denominator. And what will happen is it will cancel out all the fractions. So now you won't have this weird complex looking thing. You'll have something very easy to look at without complex stuff. Because what you're going to do is you're going to distribute this to everything. And what should happen if you do this? You multiply this item times the top, divide out the bottom. Multiply to the top, divide out the bottom. Multiply to the top, divide out the bottom. Multiply to the top, divide out the bottom. That's how it works. So in fact, I'm going to write that down so you can see that. So I'm taking the 1x plus 3 times that x, right? That's that top left corner, and I'm dividing by the number 1, right? So that's that top left corner. Does everyone see how I multiply that onto here? Okay, over here, I take the 1x plus 3 times this thing. So that's an x times a 1 times x plus 3. Divide it all by an x plus 3. Alright, that's the top right corner. Over here, I take x times the 1x plus 3, and I divide it out by a 1. That's the bottom left corner. And then down here, I take the 2 times the 1x plus 3, and I divide out by the 1 on the bottom. Now you're probably wondering, why are you doing that? Why am I writing it like this? So you can see what I'm about to do. Okay, so I multiplied all that 1x plus 3 to every top that you saw on that red part there. What will happen here, the bottoms cancel. That cancels out, so now you don't have a fraction anymore. This cancels out, so you don't have a fraction anymore. This cancels, so you don't have a fraction. And that cancels, so you don't have a fraction. So now, it's just something normal on the top, something normal on the bottom, without this craziness, where there's fractions over fractions. And all you have to do is simplify. See what it turns out to be. Does that make sense now? So it looks like up here in this corner, just top left corner, I'll have an x squared plus 3x. Over there I'll have just a minus 1x. Down here I'll have an x squared plus 3x. And over there I just have a plus 2x plus 6. And then you can combine terms, factor parts, everything cancels. I can tell you right now there's exceptions. Problems, numbers I cannot use right now as it sits. I cannot use, before I even started from, I could not use a -3 or a -2. As I kept going, it looks like eventually this mess down here simplifies. What does the bottom turn out to be eventually? X squared plus that thing factors. I think that thing factors up to be x plus 3, x plus 2. If you do two parentheses. So yeah, so these are still the exceptions. You still can't use these.
So all I did was make that x have a common denominator with the factor on the top, or the fraction on the top, and just divide it, and then I got the answer, right? Like
This, so you put this with here.
Yeah, I multiply that x by x plus 3 over x plus 3, find that, and then just divide it.
Divided by this.
Does that work? Or like,
Not technically. I think you just got lucky on that one that it didn't work out. Because technically, you'd have to multiply top and bottom by the common denominator. I know. It seems like it would. It definitely doesn't. Okay, questions? Okay, question? Alright. Let's go to number 10, 11, and 12. I think I've given you enough on that one. And I probably won't go through these next ones super in depth. I'll at least get you started on them. Tell you a little quirky rules, things you need to remember. Okay, now from now on, I don't need to worry about doing that whole domain thing. Because I don't think they asked for a domain, right? No, it just says solve it. So, now, the one thing you will need to realize is when you solve this, you may need to throw out one of your answers. You may need to throw it out because maybe it does not work. Okay? Alright, so in this problem, is the first problem factorable?
No.
No, so I can't factor it, that's the preferred choice. So I can't do it that way. I can complete the square, you do that. That might be the quickest way. You do the quadratic equation. There's no square root here, there's no no after value rules. So let's complete the square. So completing the square, you have to move the 5 over first. What does that turn into? Alright, now, the next step. Is there any number in front of the x squared? So you'd have to divide everything if there was. If there's a 2, you have to divide everything by 2, you might get weird fractions. Alright, so at this point, let's half the middle
One.
square.
One.
And that's both sides.
Why is it one?
Because you're squaring it, those two positive.
So we don't do that.
No matter what, no matter if you take half of it, you always square it, so it's positive. Alright, now, we factor this side. What does this factor up into? X minus 1. X minus 1, X minus 1, there's two of them. And on the other side, 6. Then all you have to do is solve. Solve this thing out, you do 6 power 2 to the other side, and you add the 1 across. That's your answer. Done, move on. It may be irrational, it's fine, you can't break down the square root, you're fine. Yeah, there should be 2 answers. Plus or minus. Okay, questions, comments, concerns on 10? Do you recognize it? Alright. 11. Okay, this one, since we have the equal sign, we have the actual equation here. You can multiply everything by the common denominator. Everything by the common denominator, and what will happen is it will cancel all the fractions. So first step, let's factor this apart. This can factor. What does that factor into? 2x minus 1 plus 2, so that's the new bottom. So it looks like my common denominator between all 3 fractions is literally this thing. Because they all have 2's and they all have x minus 1, so let's put this on the bottom of everything, right? Well, I'm going to do this slightly different than what we did earlier, right? I'm not going on this problem to try to simplify fractions. I'm not trying to add and combine fractions. I'm trying to get rid of fractions because there's an equation, there's an equal sign. So what I'm going to do is I'm going to multiply everything by the common denominator, which is this. That is a different strategy than what you do earlier. Earlier you just had to add fractions together, so you want to get common denominators on the top, right? This, I don't want to do that. I want to get rid of the denominator. So I'm going to multiply everything by this, because technically I multiply to one side, I can multiply to the other side of the equation, and it's still balanced. Over here, what happens when I multiply this first fraction? These cancel. So I'm left with this 3. That's why I'm doing it. In the middle, what cancels? 2 cancels, right? So I'm left with the 1, x minus 1, right? The top and the radical sign. Over here, what cancels? Yeah, x minus 1. So Johnson left with 2 times 2, which is 4. You see how that works? Now just solve the algebra 1 problem.
I don't think there's any problem.
Where? The right, oh, this side? They're down on the bottom. This is going to the top. If the 2 is on the bottom, yeah. Okay, questions on 11? That's how you're going to do that problem. No matter what sits there, it's the same style. Whatever the denominator is, you multiply everything by the common denominator, it'll cancel out whatever's on the bottom. Alright, let's go to 12, last problem of the day. Thank you, probably recognize this one. I thought I did it the other day.
Even though I don't recognize them, I'm just gonna say yes.
That one's the number.
Alright. Okay. What do we have to do first? Square both sides. If you square both sides, it'll cancel out the radical signs left with 20 minus 8x equals x squared. And then you're going to just move items around and see if you can either A, factor the part, or B, do the completing the square thing. But I'm probably going to have to move this stuff over here, because I want to keep the x squared constant. So let's move the 8 over, so it becomes plus 8, and the 20 over becomes minus 20, and then you can figure out from there. I think that's actually factorable. I think it breaks up into 2 perfect parentheses, and you can actually read off your answers like within 1 second backwards. Alright. The problem on the test. If you have a square root problem like that, same thing. Square both sides, whatever it is, try to break it apart. Factor if it's not factorable, complete square root, quadratic, whatever you want to do. Okay, that's it. You have 12 questions on this thing. You need to be able to handle those style of problems. They're not going to look identical. It's just I picked a problem from the book that was the general type. Does that make sense? I'm not trying to trick you. I'm not trying to pick the hardest problem. I just picked one. Okay? Okay, you have the rest of the time, which is not a lot, but 10 minutes, where you can work on this.
Do we have to check our answers?
Oh, like if you're going to go back and plug it in. The only thing I'd worry about is like, if you're going to do that, just make sure it's not like one of the exceptions. Like on this last problem, like if you found answers like on this problem number 11, like if you found 2 different numbers, let's say it worked out nice and pretty, and let's say one of the answers was literally the number 1, you have to throw it out. Because you can't use 1 on that problem number 11, because it was an exception. That's the only thing I want you to do.
Yeah, so we don't have to like worry about plugging it back in.
What? Did you get a practice going to do that?
Yeah, because it's like
So what I would recommend for tomorrow, look at the videos we did yesterday.
Tried it. I looked at it. I go, I'm gonna try that one. It didn't work out. But then I was like, oh, I don't know, because it didn't ask. You know what I mean?
They're still working on it, so you can kind of work.
This is my final.
Yep.
Wait.
Excellent.
Yeah, mine's way different. Yours is way different.
What did you get for
I gotta say about that actually.
because we can plug it back in.